So in order to answer question C, determine the coefficient of determination or R square, and what does the result of R square imply? Just like I said before this, just look into the value of the adjusted R square. So R square represent the percentage of the variance from the dependent variable that are explained by the independent variables. And based on the regression result that we have over here, the adjusted R squared is 49.66%. It means that 49.66% of the variance of the height of yellow Meranti are explained by the diameter and the bark thickness of the tree itself. And in order to answer question D, by referring to the p-value of the independent variables, determine whether the diameter and bark thickness of yellow Meranti is significant in explaining its height. We refer to the p-value. Yeah. So here, the diameter of the yellow Meranti has p-value that is 0.0707, and the number of stars that we have represent the significance level of the independent variable. In this case, we have 1 star. It means that the diameter of the tree is significant in explaining the height of yellow Meranti at 10% significance level, where 1%, 1 unit of increase in the diameter of yellow Meranti will lead to an increase in the height of yellow Meranti by 1.53338 units. And then in terms of bark thickness, the p-value is 0.0826 with 1 star. So it means that this bark thickness, the bark thickness is significant in influencing height of yellow Meranti at 10% significance level as well. And the coefficient imply based on the value of the coefficient, when bark thickness increases by 1 unit, the height of yellow Meranti will increase by 21.5592 units. So apart from explaining the significance, you also have to explain what does the coefficient for both of these independent variable imply. So of course, there are a number of important information that we have to know apart from the coefficient, standard error, Taylor ratio, and p-value. When it comes to regression analysis, there are a number of additional information that we have to know. For example, whether this model suffers from problems such as heteroscedasticity, multicollinearity, serial correlation, autocorrelation, so on and so forth. But in order to answer question 10, we don't have to address those issues. It is sufficient for us to look into the coefficient, the p-value, the adjusted R squared, as well as stating the multiple regression equation. I think that's all from me. So if you have any questions, feel free to email so that we can find a suitable time to do discussion, a face-to-face discussion with regards to question 10. And keep in mind, as I said before this, I'm using different kind of data. You have to do this regression on your own as well, because the information, the coefficient value, for example, that I have over here will be different. It depends on the data that we have. In your data is different than mine. Yes, I wish you all the best in answering question 10.